So I'm going to be talking about OpenTelemetry, but hopefully for everybody in the audience will be a different flavor as well, because I'm actually going to talk about the state of front-end web instrumentation, which is something we don't actually tend to talk about very often. Why do I care about this? Before I joined Elastic, I've been here for just over 3 years. I used to work at Morgan Stanley as a front-end engineer. So I don't know about you, but I was always the first port of call whenever something went wrong, because no one knew where the problem was. So I used to work on internal banking software, and quite often we get an issue coming through and it was something like, this number's wrong or this button's not working. And we automatically assume that's the front end, don't we? It's not always the front end. Like, I'm not the best engineer. I'm a good engineer, but it wasn't always my fault, I swear. Sometimes it was down to one of the myriad of backend microservices we had that was misbehaving. And the fact of the matter was, as the front end engineer, you don't just have to look at the front end piece, you need to look at the whole holistic picture. We need to look at all of the pieces and make sure we can identify where the bottleneck or the problem is, okay? The problem is a lot of us are not doing that. So traditionally when we talk about front-end telemetry, we're talking about this notion of real user monitoring agents. And these are basically small processes that we will include within our application that will capture telemetry of what's happening on the front end so we can see what's going on and identify front-end specific bottlenecks. RUM agents are good, but one, we tend to be stuck on very vendor-specific solutions. There is the notion of Boomerang.js is intended as like an open implementation, but it still relies effectively on very niche particular technologies. Furthermore, if you want to try and correlate with backend signals, you end up with the same lock-in of being locked into the same schema for particular providers. And obviously we don't want to do that. We want something a bit more open. So OpenTelemetry is a set of tools, SDKs and technologies that are built in the open in a community as part of there's actually a CNCF incubation stage project. And what it does is it allows us to capture telemetry information, specifically log messages, common metrics, and tracing to understand what's going on in our applications and identify those performance bottlenecks. Where it gets fun is that the SDKs are all in varying stages of instrumentation. And I'm going to focus on JavaScript this evening for the front-end web view. And what you'll see right behind me is this big warning. Client instrumentation for the browser is experimental and mostly unspecified. What I'm showing you is therefore experimental. It might change, it might break. But what I'm going to show you is how you can actually correlate these things together and talk about the utopia where we have front-to-back instrumentation. So we're going to talk through it using an example. This is my little toy OTel record store app. And all it is a very simple application that allows me to browse for records. It's got a featured set on the homepage. I can search for them as well. So I can look for stuff by the Beatles. There's no event scheduled, so that's a very uninteresting page, but you get the idea. It's got navigation routing in it. And then on top of it as well, I've got news stories that I can subscribe to as well with a simple alert. So a very bog standard application that we are going to instrument. The way that the architecture of this particular app is structured is that we are utilizing the OpenTelemetry JavaScript SDK on the front end. We'll dive into the code there shortly. We are passing in the information through a proxy. It's then being passed into a collector purely to show this notion of being able to do additional processing on top of the signals, maybe drop particular error messages that are not structured correctly, or if a downstream system is starting to flood the centralized service, which I have seen before. I've got a Java backend service that's also communicating, so that's where all the data is coming from in our instance. And both of these are sending instrumentation via OTLP into Elastic. And what I'm actually using is the Elastic managed OTel endpoint, which natively accepts OpenTelemetry protocol messages in. So we're using the OpenTelemetry protocol as well within this piece. Demo time. Cool. So first things first, we talked through the architecture. You'll see I've got it live and running. It's accepting messages. It's all good so far. Just for completeness, I'm going to show you what is happening with the Java backend service instrumentation. I'm aware at the start we talked about, well, we're going to focus on the front end JavaScript pieces, but we need to know how these things correlate together for that front to back picture that I said was so important at the start. So what I've got is a very simple Spring application And what I've done is I've utilized the Elastic agent, so the Elastic distribution of OpenTelemetry. And I've basically specified that as the tool option to utilize what's called automatic instrumentation. So for those who are familiar with OpenTelemetry, this is where basically the jar process is going to attach onto my Java application so that I don't necessarily need to do all the instrumentation manually within code. It will automatically attach, and certain SDKs, including the Java SDK for OpenTelemetry, will allow you to do that. I also, on top of that, do have this notion of custom spans and traces. So the automatic instrumentation will capture the automatic bog standard things. But if you want to capture something else, something that perhaps is maybe custom business events, the way to do that, as you'll see within our controller, is you would basically create your own custom spans. What you'll see here is that I'm getting a hold of the tracer for my appropriate service name, which is pulling out from an environment variable. And then from there, what happens is I'm within my get all records. So this is whenever I'm getting every record that's coming back in that page that had the toolbar at the top. What you'll see is I basically build a new span, set it as a server kind, and start it. Start is very important. So is ending the span as well. 3 guesses what happens when you don't end spans. We set the appropriate attributes that we want, which can be custom. So you can see I've set a custom URL and things like that. We make it the current scope, and then obviously we will end it. And of course, we'll record an exception if anything goes disastrously wrong. Hopefully very straightforward. Now, this will connect to the front-end instrumentation. But remember I said we needed a proxy. We need a proxy because of something called cross-origin request policies. We've all been there in this case of why is this stuff getting blocked? I've got no idea. The spans will be blocked if you don't enable the appropriate cross-origin request policies in place so that things can go through from the proxy into the Elastic endpoint. So that's why I have the appropriate headers added on here. Without these, Elastic's going to block everything. Now, let's get to the fun bit, the front end piece. So I have, as you can see, a lot of imports at the top. But we're going to scooch down and basically focus on the fundamentals. I've got a QR code for the code. If you want to dive through later, you want to reach out for questions, feel free. So the basic thing is we're going to set up our logging, then our traces, and then our metrics at the end, because metrics gets a bit specific for front end. So what we're going to do is first we're going to create a resource. So a resource in OpenTelemetry terms is basically a representation of an entity within the system. So our Java backend service, that is an entity. A Kubernetes pod, that could be an entity. In this particular instance, the front end is an entity, so that it therefore shows on our service map and we know that it's an entity that we care about in our system. And what you do that's slightly different from vanilla OpenTelemetry is we'll create it from attributes and give it meaningful information such as a name, so we know which front end it is. Imagine if you have a micro front end architecture and everything's called front end. That's going to be a fun game of chicken to figure out which one's causing the problem. So a meaningful service name is passed in. I personally like to add in version and environment because I've been the person that's trying to debug something in production and I've asked this question, did this show up in testing when we were doing UAT for this? Most likely not. But also, has this appeared in subsequent versions? Can I actually go back and trace and figure out what's going on? Personally, those are things that I like to add. The other thing that's a bit different is we have something called a browser detector. What browser detector does is it detects the browser-specific attributes because we're going to be running this app within a browser, right? And, things that we need out of the browser information would include things like, are they logging in via a mobile browser or via desktop? Are they still using Internet Explorer in the year 2025? Sadly, it still happens. These are actually important pieces of metadata when we're trying to trace back errors and try and understand what is going on. So please make sure we're using Resource Detector. I hope no one's having to use Internet Explorer. If you do, I send on my heartfelt apologies because I've been there. Right, and then what we do is we merge everything together. So that means that we'll have the attributes we specified along with these browser-based settings to be picked up in our spans. And we'll see later how those come out. Then for logs, we set up an exporter. So an exporter, in simple terms, for those who are not familiar with OpenTelemetry, is what it suggests. It's going to send the data out. It's going to send it to, in our case, the proxy URL that we're going to send it to. And because it's called the OTLP log exporter, it's going to send them in the OpenTelemetry protocol format. Really simple. From there, we then send a provider which actually utilizes your exporter under the covers and connects the resource and the telemetry that's being picked up together via the exporter via a set of processors. We then set the global provider so that it knows, hey, application, you're meant to use this provider for all of your logs, don't you know? And then what we can do whenever, unlike the traditional, which is console.log, and then it gets spit out onto dev tools, and then you wonder, hey, all my users are external. How do I know what their errors are? So remember everyone that put their hands down before and said they're not using anything. If you have an error for a user, how do you find it? I'm betting most of you weren't like me that I could run 2 floors down and literally open up the DevTools console. You've got users out there in the big bad world and you've got no idea what the problem was. So rather than doing console.log, let's try something different. So we get a hold of the logger and then we use logger.emit. And when we do that, if I get the right tab, these are our messages here. So I've got all of my messages now. I've got all the server ones coming through. But if I also look for service.name is UI and hope everything's all working, you'll see that I've actually got the logging messages coming in, including the ones telling me that the logger and the client telemetry has been initialized. So that's all now being sent into Elastic. Okay? So the next thing we have is traces. Traces basically show the pathway of execution. So to give the game away, a trace looks like this. So you have this notion of a high-level pathway of execution through an application, but it also shows the connection points between our entities. So this example you see here has the web front end, but it's also got the server. And we're able to join these together, and we'll talk about how we do that in a moment in the code. But you'll see that within the top level trace, I've got multiple child spans that sit underneath it. So all traces have this notion of a parent-child relationship, which allows you to see the pathway of execution through a complex system, firstly. Also, you can see how long things are taking. So that analogy I said at the start of, is it the front end or is it the back end that's causing the slowness? By capturing the spans and seeing how long these things are taking, we can see what's going on, okay? So how do we do this with code? So what we do firstly is we need a provider. As we've talked about, we need an exporter. So these patterns are still there. The bit that gets different is that this is a web trace provider because it's providing web traces. And then with the provider, we register context manager and a propagator. So what context and baggage are is constructs to allow for the passing of information between these respective entities that allow for basically for these traces to be connected together as we saw within that visualization. So what will happen is you've got the notion of context, which are ones for connecting the spans together. So active span ID would be an example of context that's shared. But it might be the situation that you want to share user-defined values, and they're known as baggage, just like the regular baggage that we as humans all carry around. So what happens is we specify the context manager as the zone context manager, and that's because of a lovely library called Zone.js. All we need to know is it's used by many popular frameworks, so think Angular, I believe it's still using React, a few others, and it allows for this async management of background tasks within the browser. You've then got propagators, and I'm actually using 2. One that's propagating baggage under the W3C specification, and one that's going to pass the trace context via the HTTP headers. If you are protocol kind of specification nerd, if you just look for W3C baggage and W3C trace context, you actually find the associated information around the protocols to see how the propagators work in more detail. Right. Then the next thing that we're going to do is we're going to register instrumentations. And these are basically the types of tracing that we're going to end up capturing. So here I've got the auto one. So there are several listed in the auto, but I've done it for an example to show instrumentation fetch HTTP, which effectively is going to give you what I've got here, passing these spans through. I've also got some other funky ones. I've got one called document load. Actually captures how long it takes for a particular document to load, and it's one of the ones that I did not put up. Okay, come on, document load, I know you exist. Last 90 days. There it is. So I can actually see how long the assets in my page are taking to load. Why is this important? Has anyone had this instance where images are taking an age because they've not been optimized properly? Or perhaps, unminified JavaScript files are taking an age to load? Or other third-party dependencies, things like Hotjar, etc., that take an age to load? Being able to identify what is actually taking so long is part of the reason that document load has its advantage. And we can see for each of the resources exactly which particular element it is. So here it's loading my layout Svelte page, if you hadn't guessed that this is written in Svelte. And we can see the other attributes such as whether they were successful and all these other useful things that come in via the fetch resource capabilities. Now, we also had user interactions. Yeah? Yes, it's one of the instrumentations that's available with the JavaScript SDK. So these are all because EDOT doesn't have a JavaScript client instrumentation distribution. So this is all OpenTelemetry public SDKs that are maintained by the community. It's just being ingested into Elastic. Does that make sense? So this is how Elastic joins everything up. The other one is user interaction. Again, client maintained as well, which, as you probably guessed, picks up user interactions. Now, this is a click span. It's probably not very interesting. But the thing is, think about this notion of the propagation and the connection of context that we talked about before. This is an example for when I was typing into the search bar. And what you'll see is it's picked up the input event, but I can also see how long it's taking for that respective one to get the information back from the Java service. So in that common situation where you're probably calling off to a service that then in turn is going to connect to a database or something else, you're going to be able to see at which point it's taking the most time for the return of the results for that particular query that the user has input. So you'll see this one here, Web Vitals instrumentation. This is not available via the custom the SDK. This is one that I actually wrote myself because I wanted to capture metrics. And a good example of metrics that are useful for a web application would be Core Web Vitals. So what Core Web Vitals are, and as you probably guessed by Big G, initially put forward by Google, and what they are is a series of metrics that we can use to evaluate the user experience of websites. Quite often people bundle them in and say, oh, well, that's just something that affects SEO. But they're actually a reasonable guideline that can help us see if we've perhaps got a particular website that's poorly performing in comparison to its peers, that it's not adhering to best practices. And furthermore, as well, it kind of gives us this advantage of there's associated recommendations for each poor performing web vital that you can view in tools such as Lighthouse. And that can help you understand ways that you can potentially optimize and make your application better. These are the web vitals, which I'm not going to go through in significant detail. But if you go to web.dev, there's tons of resources there and you can learn the intricacies of how they work. You can learn about, the initial versions and why first input delay was superseded by interaction to next pane and all those other lovely things. If not, come and ask me afterwards and we can go through it. So in order to do that, I have written my own custom instrumentation. So what I've done is I am using the Web Vitals library, which you can use out of the box. It's made available by Google, simple npm install, and you can start measuring your own vitals. I also have brought in the instrumentation base because I'm wanting to create my own instrumentation, which I'm then registering. Okay. Then I'm importing metrics attributes because I'm creating metrics this time, not traces. And then, of course, I've got the notion of a reader. So I've got a periodic exporting reader, which you might guess it periodically exports metrics. And what you'll see when I initialize it is I create my new reader utilizing an OTLP exporter. Again, that pattern of exporters is coming back. I'm sending to my proxy. And here I'm specifying, the interval for which I want to export this value because it's a periodic exporter. We then return our provider, which I'm then using in here. I get a hold of the meter and then I create my instruments. And what I've created here is a set of observable gauges. So one of the more simpler types of metrics that are available within the OpenTelemetry ecosystem. And then what I do is when I enable the instrumentation, I am adding a callback for each of the Core Web Vital types, which is simply calling my own utility called sendMetric. And what it does is basically pulls in all the attributes for the Web Vital, and then we call observe, and that's basically going to send it into Elastic. Now, one of the gotchas is that the user experience dashboard in Elastic is expecting stuff in the RUM agent format. So I've built my own dashboard here. You can build it on top of the data really easily. And what you can see is that I've got each of my particular values. So I've got this rating of good or poor. I'm very surprised that everything is good. This doesn't normally happen, but I'm going to go with it and take the win. And then you can also see for the different types of navigation what the values are trending over time, just like any other metric. And the advantage of these compared to tools like Lighthouse is this is based on the real traffic. This is what users are actually doing against the site, unlike things such as Google Lighthouse, where the report is generated on synthetic traffic that's generated by the tool. Right, so that is it. That should be it. Yeah, good time for my laptop to say, hey, I'm done. So that's what we've talked about. We've talked about OpenTelemetry. We've talked about front to back instrumentation with the Java service as well as with the front end client stuff. We all now know what Core Web Vitals are. We all know how to instrument. And if you want to check out the code, feel free to scan the QR there, and that'll take you to the GitHub repo.